healthcare is such a broad thing that can go wrong in so many ways. It's operating under uncertainty, and human beings we know are not very good at that. And so there's ways to move forward, but I think it's going to take a long time.
Welcome to Back to the Future podcast. My name is Victor Sadia, and I talk with brilliant minds and hearts of people who want to uproot and transform the current health and wellness paradigm. Good morning, good afternoon, good evening. Today we have Travis Christofferson. Travis Christofferson has a degree in molecular biology and a master's degree in material engineering and science. He's a full-time science writer and published the best-selling book, Tripping Over the Truth, which shows how the metabolic theory of cancer is overturning one of medicine's most entrenched paradigms. He's the founder of the Foundation for Metabolic Cancer Therapies and the co-founder of Care Oncology. Travis, thank you so much for making the time.
Thanks for having me, Victor. I'm happy to be here.
Can you tell us about why did you decide to go into molecular biology when you started off?
You know, my entry is kind of non-traditional. I came into college having no idea what inspired me, and really directionless, rudderless. And I happened to take Molecular Biology 101 from this wonderful man. He got his PhD at Princeton, and he sent the first monkey into space. He was on the cover of Life magazine. And he started the class off by this incredible, he started off with supernova explosions in outer space and how heavy elements are created, which are, the foundation for life to form carbon and nitrogen and oxygen, and went from there, and prebiotic evolution and multicellularity. And I was just completely enamored by that story, by that, that we are just this sort of manifestation of a universe that tend towards order, right? And from then on, I just couldn't get enough. I was just fascinated how the body works. And, back then, this is the mid 90s, we were just starting to sequence genomes and understand the role of DNA and how DNA evolved. And, from then until now, that the evolution of thought and what we've learned has just been spectacular. But I've always just been attracted to it. It's just that to me was a fascinating topic.
I think it's a real privilege to choose your career based on fascination and based on this experience of amazement, because many people just choose it because their parents did or because it's a good way to making money and be part of this industrial society. But I think that curiosity and those things really drive not only the motivation, but also the creativity to, really have your say into how these fields evolve.
You can't have it any other way. I tell my kids that all the time. And that's one of the most, sort of profound lessons that I've learned in life is there is no replacing inspiration, curiosity, and passion. You just can't. When you're not truly inspired by a subject, you're only going to go so far. You're just sort of ticking boxes. But if you're really, really inspired and passionate, that's when you get those sort of paradigm shifting changes that change the world, frankly.
What got you to write Tripping Over the Truth? What was that curiosity, fascination that drove you there?
Tripping Over the Truth, I was in my, I think, early 40s, and it was really a midlife crisis. I was in a vocation I wasn't happy with, again, back to this inspiration sort of theme, but I was looking to re-enter the world that I loved, which is biochemistry, molecular biology. And I had not finished my master's. I had 3 credits left, and the university where I was at was nice enough to give me an independent study class. And so let me choose my own topic. And I was just happened to be leafing through Kindle one day, and I saw this book called Cancer is a Metabolic Disease. And it was $70, and I hovered over it. I almost didn't click it because it was so much money. I finally did. And I read it. It's this huge, comprehensive, almost textbook, like tome of work, and read it within that day, reread it, I think 2 or 3 days later. And what that book really was it was by Thomas Seyfried at Boston College. It was this non-standard look at cancer theory. And when I had been in college, it was just unquestionable that cancer was a disease of genetic mutations. It's called the somatic mutation theory of cancer. And everybody was taught that. It was dogmatic. And this looked at cancer from a completely different angle, that the mutations were in effect a side effect of a more prime cause of cancer, which Tom Seyfried asserted was metabolic dysfunction or damage to these energy-producing little organelles called mitochondria. And the data that was laid out was so fascinating. There was decades and decades, really a half century of data that you could look at in this kind of story format to support Tom's assertion. And so that, and nobody was talking about this at the time. It was he had just come out with a book. I think it was 2012. And so I did my thesis on that. I just dove into it, and that inspired the book. And Tom had written this textbook, and I think The Emperor of Maladies had just come out, which is another very extremely comprehensive book on the story of cancer, where we are, went through the entire history to where we arrived today. And so I thought that Tom's book really lended itself well to that story-like format, because it's a redemption story. There was a German scientist in the 1920s that claimed metabolism was a prime cause of cancer, this guy named Otto Warburg. And he was really dismissed. He was a brilliant scientist, regarded as one of the finest biochemists of the 20th century, and won Nobel Prizes, was nominated for more. But his cancer theory was discarded, and looked at this sort of stain on his career. And then it made this resounding comeback in the 90s, 2000s from Tom Seyfried, and is still making a comeback. It's still an evolving story.
It's amazing that Siddhartha Mukherjee's Emperor of All Maladies as a biography. It's interesting how, and you know this because you're also a journalist, if you try to tell the life of someone, you are all, in a sense, your own lenses are creating what the story should look like. And you've referenced how this book basically just deals with cancer as a genetic disease. I think it's interesting that, I think there's an update coming for the book, and I'm sure they will integrate new things. But I'm curious about what would you have written about cancer if you would have undertaken that massive work of doing a biography of cancer?
Well, I think he left off, in my humble opinion, Siddhartha Mukherjee did a brilliant job of the history, and I never, ever could even hope to replicate that. He's one of the best nonfiction science writers in the world, I think. But when you come up to the 21st century and you look at the data, he briefly touches on the data from the Cancer Genome Atlas Project, which was a project that was kicked off on the heels of the Human Genome Project, right? The Human Genome Project was this project to sequence the DNA of a single human, to look at our genetic code, the entirety of 22,000 genes. And sequencing technology had progressed so far by 2006 that it was feasible to kick off a project where you sequence a genome of cancer cells. And we could finally find the genes that were thought to be responsible for cancer. And it was very much thought, because of work in the 80s and 90s, that we'd find a very defined sort of sequence of genes that was responsible for each type of cancer. Of course, there could be some variation, but it would make sense. You'd be able to draw a line from cause to effect. What the Cancer Genome Atlas Project showed, which ended in 2015, was there was way, way more what we call intertumoral heterogeneity than was thought. And that is when you look at the genetic mutations from one person's cancer to the next person's cancer to the next person's cancer. And that very fundamental idea that you need to have cause and effect, in my mind, was kind of thrown out the window, because you'd have samples of cancer that just didn't make sense. They'd have some with no mutations, some with no mutations to driver genes, which are the ones that are thought to be responsible, some with one or two mutations to driver genes. And he didn't really touch on that. He didn't go into this confusion that was created. And I think there's some institutional inertia from that. You have millions of dollars of sequence machines, you have people's publications and lifetime of work dedicated to this theory. And slowly it's trickled out. There was an article not too long ago, I think in Nature, that the Cancer Genome Atlas Project prompts a rethink in cancer biology. If I would have done it, in hindsight's 2020, but I would like to see more of that, of this confusion created and sort of this shifting of paradigms of thought about what cancer truly is.
It seems that for paradigms to shift, we also need outsiders to come in and poke into the paradigm of the disease or whatever, and have a few says. Like Warburg himself was a physicist, not a physician. And I think we're seeing that also with other, like Davies, also who's stepping into as a physicist to explain all these things into the cancer paradigm. How can we still, or better, how can we keep co-creating new paradigms and inviting outsiders to the conversation without dismissing them as outsiders and less knowledgeable about what we're talking about?
Paul Davies is a very interesting story. Yeah. And he was conscripted into the cancer effort in 2000, I believe 2006. And Anna Barker, who was then the deputy director of the NCI, National Cancer Institute, she was very frustrated by the lack of progress in treating cancer. And she thought, just like you said, we need people to look at this with fresh eyes. And she conscripted physicists for the reason that that's what they do. They look at these very complex data sets and try to make sense of them, right? And Paul Davies is, he's a very high level physicist. He worked with Stephen Hawking for a while. So him and Charlie Lineweaver were one of these, I think, 6 sites where they call physical science cancer centers. And that was the idea. They really weren't given any straitjacket on what they had to do. It was just try to look at cancer and come up with new ideas. And so when Paul Davies looked at it, the first thing he did was look at the data from the Cancer Genome Atlas Project and just said, this is crazy. He goes, this is insane to try to look at these, try to make sense out of petabytes, insane amounts of data and make sense of what cancer is. And you look at what a cancer cell looks like, right? And it's remarkably consistent. There's these hallmark features of cancer, which is the most cited paper in cancer biology. They show these very consistent features they have replicative immortality. They evade the immune system. They shift their metabolism to glycolysis. They do all this stuff consistently. Now, just coming from the somatic mutation theory to think that a random series of mutations could reinvent this consistency over time seemed absurd to him. And that's what he said. He said, his quote was, there has never been a clear example in science of looking at the trees at the expense of the forest, of focusing on the trees at the expense of the forest, with cancer biology. So to me, that was almost validation. That came after I wrote my book. And I was like, I'm just waiting for someone to say, here's what you got wrong. This is what you got wrong, right? But when, a physicist at Davies levels looked at this and said, no, you guys, there's some very severe problems with this theory. We need to think about other theories. And his theory to me makes a ton of sense, which is that cancer is really an atavism, meaning that you look at it from this view of how life evolved on Earth. And again, he goes back to this quote from Dobansky that nothing in biology makes sense except for in the light of evolution. So when you look at how life evolved, for the majority of the time on the planet, there were single cell organisms, and their imperative is replicative immortality, divide, divide, divide. Then a single event happened. And this is what happened was, this is another biochemist that came up with this, that event was mitochondria came, the endosymbiotic theory, where a bacterial cell became endogenous into another bacteria. They divided up labor, and one of the bacteria became devoted to energy metabolism, and that became mitochondria. That allowed for multicellular life to kick off. And what that entailed was cells now had to sign contracts essentially with each other to give up replicative immortality, to live within a collective, a cooperative. And these are very tenuous contracts. They're tumor suppressor genes, right? When that breaks down, that leads back. So evolution sort of goes a vector backwards, leads back to this state of replicative immortality. And it's very interesting, this is something that doesn't get brought up a lot, but when you look at how genes expression shift in a cancer cell, they shift back to an early embryonic state. And early embryonic cells look just like cancer cells. They evade the immune system. They're highly glycolytic. They exhibit replicative immortality. So it's not that cancer is being invented by mutations every time. It's an atavistic reversion back to a cell, which makes it a lot of sense when you look at all the data.
Just a short. I'm very happy because I heard you a few years ago with Aubrey Marcus. Then I read your books, and now I hear you speak directly to me, and I feel very excited. Thank you. Regarding this atavism, and I think basically, evolution probably is one of the largest forces on Earth in life. And it makes sense to give an evolutionary explanation to a disease that it's as big as it is. And what I also find interesting, because I'm a sociologist, and this explanation of atavism and basically dusting off the instruction, the genetic instructions when we were unicellular organisms, triggered by this chronic sublethal stress that we are exposed to, is basically just telling us when in danger, just go into survival mode and kill everyone because you need to survive, like when we were unicellular organisms. And when you use those words to describe it, you can't really hide from the fact that you can also explain this not only at the biological, genetical, cellular level, but also on the sociological and even environmental realms of reality, where it seems that even the human species is, in a sense, reverting to that primitive state, and we're putting in danger our society and the planet.
Yeah, those themes, that's a huge topic. Those themes, I think with science, what you kind of learn to respect is that there's a consistency in the themes of nature, right? And when you look at how life evolved, again, back from unicellular to multicellular, and then up this ladder of incredible complexity to this pink ape that can think for itself, and now he's in a cave and he's inventing tools. He's using tools. They learn to communicate. From there, you fast forward to today and think of what's happened, the technology, the building of civilizations, right? And that's another theme. I mean, to go from unicellular life to a multicellular organism where you have a division of labor, a liver cell is doing a very specific function, a neuron is doing a very specific job. And now you have human beings that are doing the same thing, almost like cells. You have somebody in AI, you have somebody, sweeping the streets. So it's a theme, right? And you can't separate the two. They're both evolutionary paradigms. And from this point, we can be optimistic of the future. We can be very pessimistic. I think every generation feels that. And I don't know what's going to happen, Victor. I don't know. I don't know where we evolve from here as a collective, I guess.
I don't know what's your opinion on this? I haven't really heard you talk about this, but in a sense, feeling that or thinking that cancer is not this foreign invader who's really messing up with ourselves. And in a sense, it's an evolutionary response to survival based on the current situations of our environment. I think it can also help us to de-demonize cancer and probably not be so afraid of something so foreign, and also understand that if it's coming from us, maybe there's a message there, maybe there's some teachings that we can really learn. Not only in terms of our emotional reaction to the disease, but also obviously in terms of how we characterize cancer in the society, in marketing, and all those things, and reappropriate those meanings as part of this evolutionary story, because it's also a story of how we have been talking about the disease all along.
Yeah, historically, it's always been framed as a war. And that kind of came from the single cell hypothesis that unless you kill every single cancer cell in a patient, you're going to lose the war, because that one cell can divide, you can have a recurrence and death. And they get better at dealing with chemotherapy as the time goes on. So it was framed as a war. You got to cut, slash, and burn was kind of the jargon that oncologists use. Cut it out, burn it with radiation, and poison it. I'm sorry, yeah, it was cut, slash, and poison. And that was the approach to cancer therapies for a long, long time. In the 60s at the NCI, they'd push chemotherapy to absolute limits. It was an experimental, time where a lot more was allowed, more permissive, and they would push patients to the brink of death. And they really only were able to make a significant progress on a handful of cancers. And then the utility of high dose chemo was really realized at that time period. I agree. We need to stop thinking of it as a war to kill every single cell, because when you look at cancer more as an epigenetic or metabolic disease where gene expression has gone wrong, what about engaging cancer cells in a sort of diplomacy where you shift that gene expression back to behaving like a normal cell? And that has been shown to be entirely possible. There's a new classes of epigenetic drugs. There's all kinds of lifestyle things people should know about but don't get exposed to. If you have insulin resistance, which 80% of the US population does to some degree, that is highly prognostic of cancer outcomes. That's something we can all deal with very simply through lifestyle. And all kinds of things like that. And sociologically, right? People, we're not just individuals. We are, again, we're back to this idea we're a collective. People that report being lonely, that are not happy because they're lonely, have very significantly worse prognostic outcomes than people that are not. So there's a whole different side, the way you could frame the way you approach cancer treatment.
Yeah, and coming from this bacteriological paradigm of disease in general, we're also seeking that foreign agent like a bacteria or a virus, and we want to kill it. But we seldom think about this theory of the seed and the soil, and what's the soil, and how can we empower and boost the soil, not only individually but collectively, so that these things don't really proliferate. And that's why I think stories are so important, because in a sense, we have always separated biology and genetic and physiology. Like those are things that scientists in hospitals and labs are working on. And words, meanings, advertising, marketing, and even political discourses are really separated from that. But for example, you think about the placebo effect and you see it in action, like a smile, like a dance, like even a political or an advertising campaign can prompt changes in our physiology, in our genes. So I don't like when we dismiss stories as nice things, but as if they were separated from reality. Where do you find this connection between the power of narrative and words with the materiality of cells?
No, that's a fascinating question. Most of the time scientists are reductionists. They're looking at, well, if I add compound A to a cancer cell, what does it do? And go from there. And that's how they approach sort of scientific research and then therapies. But you're right, there's a big broader sort of narrative to therapies in general, to being what is it to be a healthy person and so on. And surprisingly, and I learned this in my second book, Curable, that the biggest determinant of how long you're going to live is social, is the amount of close contacts you have. In other words, the people you count on the most that you can go to if we're alone, your close family and friends. And the second is something called social integration. So it's as you move through your day and your life, how much social contact you have with the world, right? Do you chat with the mailman, kind of those type of things. And those two by far are the biggest determinants of health. They will tell you that if you don't have those, if you feel like you don't have those, and it's kind of individual based, it's not absolute, it's not a number. It's introverts need less of that than extroverts, right? So, but people that report loneliness have a 50% higher risk of death before 70. Now, to put that in perspective, what we consider public health enemy number one, obesity only confers a 30% chance of risk of death before 70. So it's a huge, huge determinant. How do we factor that into, and this goes to cancer too. When women that report lonely for breast cancer have recurrence rates are higher, median survival is lower. There's a fascinating experiment with rats which are highly social creatures, where they group them in cages of 4. And these are rats that are prone to mammary cancer. And then the other rats were left in cages isolated. And they just watched them over time and then autopsied them. The rats that were left alone experienced, it was 3,000 and some percent more tumors, mammary tumors, and I think 100%, 135% bigger size of each tumor. So that's an underappreciated sort of narrative, I think, is what you're asking of our lives. It gets lost in that reductionism of science.
I agree. And whenever we see this complexity and we want to interconnect all these things, narrative, biology, genetics, social determinants of health, public policy, environment, and we want to go to those scientists who are reductionists, they're very important and they're very necessary. But at the same time, they have this analytical way of reducing everything to a single cause, to a single effect. How can we be, as paradigm shifters, if we can use that adjective, critical of those positions? How can we show them that they are, in a sense, blind to all these interconnections without being so forceful, without mocking them, because that really generates more separation. And I sometimes hear of all these new doctors talking about the new metabolic paradigm of cancer, and we can't really restrain ourselves and not be very critical and even we have narratives that might expose people in an emotional way instead of an intellectual way. And that really separates us in research and in community. How can we push for new paradigms without criticizing in a bad way the paradigm that we want to supersede?
That's a great question. And, you look at the history of science, and any paradigm shift in science was a battle. I shouldn't say all of them, but the majority, especially in health, are protracted battles. And there was a classic one called the Oxphos Wars, where Peter Mitchell first proposed that mitochondria generate energy through this crazy chemical process called the chemoosmotic gradient. Nothing like that had been proposed before, which is all we knew at the time was basic substrate chemistry, right? ATP had to be created by one single chemical reaction. So he came up with this idea, no, there's this intricate, elaborate thing that goes on in the mitochondria where we pump hydrogens into this space, and it's creates this like balloon, it expands and then there's force coming back down because of the pressure. And this spins this wheel of ATP synthase, which creates ATP. And people said he was insane. And people would go to these conferences because fights would break out. And it became personal. They attacked him personally. And I've a couple friends that actually knew Peter Mitchell at Johns Hopkins, and Peter would go and just seek solace in the office. And they'd say, Peter, we know you're right. You just have to hang in there. And I don't like sort of Tom Seyfried's image of cancer framed as, haha, look, this is correct. You guys got it wrong. Science does not need to proceed that way. It's a democratic process where we just look at this and talk. And I think it comes a lot on the individual, right? How they present it, how they frame it. Are they doing it antagonistically or not? I think you're right, Victor, that things have changed where that we used to have sort of a common source of information. And journalistically, we'd watch the nightly news and it was the same anchors and we all watched that. Now, newspapers are gone. They're heading the way of the dinosaurs. We get our information from the sources that we want to get it from. And it's just this constant reinforcement bias. And it tends to devolve into this tribalism of us against them. And I think that's happening in every aspect. And it's really imperative on us to not, I just don't participate in it and I refuse to. So same thing with science. These paradigm shifts need to be approached in just a delicate, very empathetic way.
Yeah, it's very easy to criticize the bad CEO who's, I don't know, pouring chemicals in the river or selling cheap and junk food to the public just because he wants to get rich, or the corrupt politician, or even the irresponsible individual who can't stop eating. Like, those are reductionists blaming instances where it's easy to fall on them. They make perfect sense, but they don't construct anything. Rather, they really separate us. And I think in one of your books, you talked about the problem with fee-for-service in a specific hospital. I think it was the Reading Hospital, where they have a culture, they wanted to maximize the scans or certain procedures, and they were billing more than they were really needed. But let's talk about that example and not really seeing that there's bad people, bad doctors, bad administrators there, but basically a system of how we are doing things.
Yeah, that's a great one to bring up. That was a fascinating case study, right? Where doctors have known for a long time that it's kind of hard to diagnose when to put a stent in or when to do heart surgery. And so in Redding, California, what happened was it's a clinic, a cardiovascular clinic there, and patients would come in at any tiny radiological sign of heart disease, they would immediately shuffle that patient to the operating table. I mean, it was so far beyond what anyone else was doing. They're basically operating on almost everybody. And their data started to look better because they're operating on people that are entirely healthy. So fewer and fewer people are dying. They're like, look, we're doing the right thing. When regulators finally caught wind of what they were doing, automatically they assumed, oh, these guys are just fleecing the fee-for-service system. They're doing this to make money, right? And the journalists that dug deeper realized that wasn't the case at all. These guys were not financially motivated. Simply a culture had developed this sort of peer-to-peer reinforcement that they thought they were doing the right thing. There really wasn't any bad guys. These guys genuinely believed they were doing a service for humanity, even so far as one of the people in the C-suite flew his mother in from Chicago to be operated on because he thought these surgeons were the best in the country. So that's an example of, you just can't judge things from the outside. You don't know where things have gone wrong. The flip side of that was McAllen, Texas, right? Where you looked at the Medicare reimbursements rates, and per Medicare patient, it was $15,000, which is double the normal amount in the US. And you go down about 800 miles to El Paso, Texas, same demographics, same socioeconomic status. The utilization rate's 8,000. So it was double that. So what was going on in McAllen? They went down there and they found out it really was a culture of money. The doctors had this very strong entrepreneurial, and they competed with each other. They were, looking at each other's how much they were making. And so this spun out of control to where these guys really were, fraudulent, frauding the system and just over-treating to an insane degree. And again, the regulators came down on them. Journalists wrote great pieces on them. And that worked, shining a light on when people are doing bad like that, just sterilizes it. They fixed it back to regular utilization rates. But, healthcare is such a broad thing that can go wrong in so many ways. It's operating under uncertainty, and human beings we know are not very good at that. And so there's ways to move forward, but I think it's going to take a long time.
That's why I think it's fascinating that you brought in Kahneman and Tversky to one of your latest books. Because, if we want to challenge dogma and if we want to see those blind spots and all this inefficient way of doing things in the huge healthcare system, we really need to understand cognitive biases. And the funny and ironic thing is, even if we understand them, we can't really prevent them. We cannot. So what do you like about this heuristic cognitive biases seeking? And then how can we convert those findings into new procedures, processes, or policies to sidetrack them?
Yeah, no, well, there's some good examples of how to do it right. And one of those is Intermountain Health in Utah, and they do it right. If every hospital, the entire US healthcare system adopted their model, instantly tomorrow we'd save 40% and have better outcomes. Right now, we spend almost 20% of our GDP on healthcare, double what most Western nations spend, and have the worst life expectancy in all Western world. So clearly, just from the top down, we're doing something very, very wrong. The way they approach healthcare, and the way I think it's got to evolve, is healthcare evolved. Go back thousands of years to the Greek Hippocrates, and he had a statement that a physician's judgment matters more than any external measurement. So we had this ethos of a doctor as this autonomous island of sovereignty where they just operate completely independently. Now, of course, we've developed specialties from there, surgeons, radiologists, and so forth. But we need to go even further from that. We need to have the infrastructure help doctors with the complexity they face day to day. Medicine back in the days of Hippocrates looks nothing like today. We have 6,000 drugs that are approved in various agencies, something like 9,000 procedures and diagnostic procedures. There's no way that physicians can handle that complexity. So at Intermountain, what they do is infrastructure works to reduce that complexity, to help that decision-making under uncertainty. For example, nobody knew the best time to give antibiotics preoperatively. Was it 24 hours before the surgeon started to cut? Was it 24 hours after? Everybody just kind of ballparked it. Nobody knew. And so what they do at Intermountain, they do this brilliantly day to day on all these things where there is any uncertainty, is they just look at the medical records and they have doctors that did it 24 hours before, doctors 24 to 48 hours after. Then they determined by the medical records that you could reduce surgical infections by half if you did it 24 hours before. So they constrict that decision-making under uncertainty, provide guardrails for the physicians. Now, some physicians push back and say, you're reducing our autonomy. It's our intuition that matters. Well, no, the data is clear. In many cases, your intuition can be much worse, right? So we can do that with data, make these guardrails where it matters. But then, there is something magical about human intuition where they have that intimate bond with relationship with a patient. And then we can let that flourish under those guardrails and say, this is what you need to focus on, that intuition. We have your back on these other areas of uncertainty. And there's so many examples where just tradition, has dictated medical procedures. Like forever, for advanced kidney cancer, it was thought that, you need to take out the kidney. Then in 2018, they finally did a trial and said, no, removing the kidney is no better than just the chemotherapy they're already getting. And usually it's less is more. Most cases we're over-treating. So we need these kind of comparative trials to show us what works and what doesn't. And then, give physicians help to where they don't have to make decisions where it's a judgment all the time and it's not known if it's right or not judgment.
I think the new paradigms are very much reliant on finding these balances between how much attention we put to data and all these marvelous things that we can now do with artificial intelligence and big data and machine learning, and also pair it with human artistic intuition. Like there's a balance there to be cherished and not trying to just reduce it to one or the other. And you mentioned a pivotal word there, which is sovereignty. Like the doctor wants to be sovereign of its own decisions, and I think that's great. But I think in general, what we're seeing in this understanding of collective producing health is that the sovereignty is at all times in many heads, like in doctors, in governments, in teachers and educational institutions, parents, patients. Like every one of us has to understand that we are sovereign and that we are responsible for our and the health of others. And that's also a thing of narrative, not outsourcing your health to your government or an outside institution or person. and really reappropriating this sense of health. It's created by me, for us, by us, in a sense. How do you see this discourse of empowerment, of distributed empowerment, I must say, to create new ways of science and technology to come together?
Yeah, that great question. Back to the first part where you're talking about the sovereignty and human intuition, and there's a very interesting example of that where AI has gotten so good at computer chess it can beat most grandmasters. But there's a new form of chess called advanced chess where the best chess players in the world pick their AI program and then play alongside it. And they've played alongside it so much that they can identify when it might be getting it just a little bit wrong. So there's an element of human intuition. That combination is better than the best AI programs in the world. So I think that's a beautiful example of how this can sort of exist together, right? As far as taking control of our own health, I think is so critical for everybody. And I don't know how to solve that. We don't know typically what matters for our own health. I think there's a lot of miseducation of that. It's funny when you interview super centenarians, people that live over 110, that's 1 out of every 7 million people. You ask them, what made you live this long? And you get answers from, I drink Dr. Pepper, to one guy was 12 cigars a day and whiskey at night. Another's sunbathing nude. And the truth is they have no idea why they live that long. That's where human bias comes in. I think it was the Dr. Pepper or the hogshead cheese was one answer. But again, approaching that question from epidemiology, we know what matters. It's interconnectedness, the blue zones where people live the longest. It's not the food, it's the density of architecture and the focus on people stopping by, extended family. I think people knowing this, designing our communities, being involved in the community is critical. That it's not we don't need to stress about the little things another much. Did I exercise at the right time? Did I eat the right exact thing? That's really not what matters the most, right? So I think it's got to be educational. I think we just need how to learn to live better and what matters.
And there's also this need to find the thing that is going to make the biggest change, like one thing, like one cause. And I think it's getting to be more comfortable with to the fact that there are a lot of things that make you healthy and live longer. The best way you can have a balance between all of them, that's better. Because even in marketing, we want to reduce it to one single thing, my product, my exercise, my diet, whatever. And that's also reductionist, which is something that we want to step out from. Tell us about your foundation and what do you do in your foundation and why did you change the name?
Oh, the name. Yeah. So the foundation I started when I wrote Tripping Over the Truth. And the idea was a lot of the therapies that approach the metabolism of cancer are essentially patent. You can't patent them. They're free. So it's very hard to get funding, right? So we were looking at ketogenic diets, which have shown promise for cancer, looking at drug repurposing, that kind of thing. And so it kind of had to be a grassroots effort. So I thought if people were inspired by the book, they could donate to this foundation. And it's turned out to be, way surpassed my expectations of what I thought it would do. So we've had some very generous philanthropists. We're trying to fund a huge ketogenic diet study for brain cancer at Cedars-Sinai. That would be profound to show if you could really change outcomes by just a dietary shift, right? And it's free. People can learn it and do it on their own. So that's what we're doing. The name change came from, I didn't want people to get the impression, the original name was Single Cause, Single Cure. I didn't want, again, back to this kind of where people can devolve into this tit for tat war. I didn't want them to think that we were espousing a single cause and a single cure. Even, there's going to be obviously combination therapies, multiple, hopefully we get to multiple things like that. And single cause is still up for debate, right? I mean, I think we're getting closer to what we know a cancer is through these sort of paradigm shifts, but I don't think we're there yet to say we know what the single cause is.
I'm not an expert, but in this interdisciplinary co-creation of new paradigms, I must say that to me it makes a lot of sense that not only cancer, but many other diseases are basically this exposure to constant stress, which is sublethal. And what we're finding is that stress comes in different ways, like from a toxic thing that we can ingest in our food or water to toxic feeling, like we can't really apologize to someone or even receive the apology from someone, to whatever we're eating, the electromagnetic field we are living on. So that's the thing, like many things are stressing us and we will need science and intuition to look for those. And the funny thing is that we won't be able to reduce or eliminate everything. So in a sense, it's also making friends with all these things that are making us stressful as a society and using our narrative to accept how things are. Like, what happens if you're in an airport and there's nothing to eat and you haven't eaten for 24 hours and there's only French fries? Should you take it or should you not take it? And it's probably, I don't know if it's better or worse, but the narrative about those French fries that you wouldn't like to eat might be also endangering in terms of stress. Like if you don't eat anything, it might be also dangerous. So like you're talking about this balance, and it's also about not knowing, as you have referenced. So being open to the unknown and playing with that without uncertainty is I think, another stepping stone into new paradigms.
Victor, there's interesting studies on stress that are to me just absolutely fascinating. So the study looked at, I think, 40,000 people, and they rated their level of stress, high, moderate, or low. And then they just tracked them and counted who died and who didn't die. The people with the highest level of stress had a much higher death rate than the people with the lowest amount, except the people that thought stress was not bad for their bodies, right? They had actually the lowest death rate, even the people that reported low stress. So how can that be? And then you look at, okay, what happens in the stress response? What happens is you pump out adrenaline. We're all familiar with that feeling. Your heart rate goes up, your blood pressure, you feel uncomfortable, but you also pump out oxytocin. So stress prompts you. Oxytocin is the love hormone. It makes you more empathetic, makes you reach out to be more social. If you seize on that, when you're going through a divorce, I've seen my friends do it. They reach out, they want to talk. They just want to talk about it. And so when you do that, when you reach out, you become more empathetic and you help people that are also stressed. Your stress, then your death rate goes back to baseline, right? So it's everyone thinks, oh, I'm feeling the stress. It's horrible for me. No, it is gearing you up to face whatever challenge you're facing. It's not going to hurt you, right? And it's you need to follow the cues of stress. You need to reach out, and that is therapeutic in itself. So yeah, our bodies were designed to go through stress, and I think it's something we don't need to worry about. We just need to listen to it.
Travis, I want to thank you for this amazing conversation. We really touched upon different subjects, but they're all related. And I wanted to ask, what are your next steps? If you could write, let's say that you'll write, 3 more books in the next 5 years. What would be those about?
Oh my goodness. I think I'm like you, Victor. I'm a curious person. So I'm always I go from one thing to the next and I get fascinated, right? The cancer story is becoming more and more fascinating as we learn more. So I've always thought about doing sort of a sequel to Tripping Over the Truth of where we are now. The second book, Curable, again, there's so much content in that book about how the healthcare system's gone wrong. And again, individually, what can we learn about epidemiological data for our own health? That's still a changing story with tons of fascinating things coming out. I guess I haven't, when I write a book, I always take a long pause and just sort of see what comes next. And I'm still in that see what comes next phase right now.
How has your personal life changed in the past 10 years based on the research you've done and the works you've published and the people you've talked to, in terms of your routine, your habits, your relationship with your kids?
Yeah, good question. So I'm 50 now, and I think that at my age, my kids are, they left the house, they're in college, they're doing their thing. You just realize how fleeting. I felt like my kids were little forever, how fleeting life is and how fast it goes. And I know that's a cliche. Everybody says that. But what really matters, you realize, is just the relationships. Like when I wrote the book, Tripping Over the Truth, the relationship that I developed from the people I met with Tom Seyfried, I'm able to help him out through the foundation. I just cherish those things. And that's really all that matters, right? The day-to-day, I think we all have to go through that, but you just have to, that's what matters, is this collective effort. And there's nothing better than having engage like this conversation, right? It's things like this. I just cherish things like this.
Yeah, I'd say that I'd follow the same path of just following my curiosity. But then what you find is that I always paraphrase Gabriel Garcia Marquez, a Colombian writer, who said that he only writes book so that his friends love him more.
Huh. That's a beautiful way to look at it. Yeah, every book that I've written has come with long-term friendships, the people that are in the book. So yeah, and I think the lesson there is just engage the world. I never regret not trying something, right? I do regret the things that I have not tried. So don't be afraid to engage. And if you feel stress from it, again, back to the stressing, that's a good thing. The stress, you can handle it. Trust your body to handle it.
Thank you, Travis, for this conversation. I'm very happy that you responded to an open email I sent to your publisher. You never know if those are being seen or not. And as you say, that reply was just your openness to keep meeting people, having interesting conversation, and just building relationships for the future. So I'm happy to now call you my friend. I hope you can call me your friend too. And I'm sure we'll be talking a lot for the next few years. And you can count on me and this audience for whatever we can help in your cause, your foundation, and the way you are putting forward your knowledge and your epiphanies.
Thank you, Victor. I appreciate it. And yeah, we'll stay in touch. We'll keep chatting.
Have a great day.
Thank you. You too.